Good afternoon. Hello, everybody. My name is Phil Ward, and I'm a technical account manager with AWS. I've been on the account team supporting Supercell for the past 2 years now. One of the highlights over my time supporting them has been helping to plan the launch of their latest game, Squad Busters, which is what we're here today to talk to you about. I had the pleasure of being joined on stage by two of my colleagues from Supercell. The first is Tony Sivinen from Supercell's cloud governance team, and also Tomi Jokishopla, one of the 3 server engineers supporting the backend AWS platform for Squad Busters. As for an agenda today, we'll start off today with Tony giving some background about Supercell and what makes Supercell special, and then giving some background on Squad Busters as well and what the game is like to play. Then Tomi will walk us through a detailed technical architecture of the game and how they prepared the game for launch. And then I'll talk about AWS Countdown and how we, from the AWS support side, help support the launch. And then lastly, Tony will wrap up and give us the results and how everything went on launch day. So with that, I'll hand over to you, Tony. And as a reminder, sorry, it's a level 300 talk, so we will get into some pretty good details of the talk.
I don't need the mic, I just need the power. Yeah. Good afternoon, everyone. My name is Tony Syvänen. I'm a senior cloud governance engineer working at Supercell. I started earlier this year in Supercell, but I have over 10 years of experience of AWS tech, from which 5 of those are working with different Nordic games industry customers, the studios working on that. So I've been empowering games customers quite long to use AWS technology. But let's briefly talk about Supercell. Here is Supercell's mission statement. We can actually take a moment to quickly read it through. I'm not letting you to read it. And as you can see, it sets the bar pretty high for our games, that what are we looking for when we build games. Because we basically want you to play the game for multiple years and make things that you remember forever and talk with your friends that, oh, we did these cool things in the game. So it has a really high bar for our games. Quickly on the history, we were founded 2010, so 14 years ago. And since then, we launched steadily every 2 years, game or 2 games. So we had 5 games launched steadily every 2 years. And then we had a bit of a hiatus since 2018. We didn't launch any games, and there was a lot of expectations from the world that where is our next game? When will we launch our next game? And then finally this year, we launched Squad Busters. On the pictures, you can quickly see actually our CEO over there is on, I presume, his first work desk, being a bit frugal on his way of living, and then new office in Helsinki nowadays. And today we are 650 people around the world, over 45 nationalities. Here we got just 2 months ago back together around the world because we have studios in Helsinki, Shanghai, San Francisco, and Korea as well. So we have people around the world, so we got together just a couple of months ago just as a team. And what makes Supercell special? We feel that game developers are artists. And as an artist, we want them to make the decisions that are the best for those games. So from that point of view, this kind of traditional organization model doesn't really fit our way of working, because do artists ever make good products, good art, when you tell them, oh, I want to have this in the game, it has to be that in the game, et cetera, et cetera. So we actually have a different model. And that model is part of our game name as well. So the cell model, being in the name, Supercell. So that means that the game teams themselves have all the power to make all the decisions, starting from what kind of game they make, what kind of technologies they choose. Like in this case, we are talking here of AWS technologies. So Tomi has made the decisions as part of the team there that they're going to run with AWS technology. So we want to really empower the teams to make what is best for their games. And with that model, we have launched, before Squad Busters, 5 games globally with over 6 billion installations. And we still get over 200 million monthly active players across these 5 games. But what you don't normally see, and typically don't see, is how many games are beneath them, killed before they even made public, or sometimes even made public. They were soft launch, but they never made it to the global launch. So there's over 30 games that we have killed. And when I say we, I actually mean the game team themselves made the decision. It's not an executive somewhere saying, we don't go live with this game. It is actually the team themselves deciding, doesn't meet our high expectations, let's not go live with this game. So that's kind of like the story behind here. Like, yeah, we feel that the game teams make the best decisions, even in terms of do they launch the game. And this year we made the decision, the game team made the decision to go live with Squadbusters, which is our latest game. And let's take a brief look at what is Squadbusters all about.
Barbarian, classic, super, ultra. Gem line open. Crushing it. Busted.
So yeah, that is Squadbusters in a nutshell. So to summarize it, Squadbusters is a 10-player multiplayer game played on mobile, where you game in the world to compete with other players, to collect gems, and in the end, the highest gem number wins. And it is also player versus world, player versus player as well. So there is all kinds of action that you can have during the game session. And if you go a bit deeper on the details, it is a global player base as well, so we're not separating the players in different regions. If you have friends in Europe or you have friends in Asia, you can play with those friends together, you just party up and you go into the game as well. You quite saw that there was a lot of typical heroes from our other Supercell games, so you could play as a barbarian from Clash of Clans, you could play as the chicken from Heyday. There's no limits for that, so you can play with different known characters from the games, and also the game worlds are inspired by our existing games. So you could play in the Boom Beach world, in the like war area, so to speak, in there if you wanted. So that's one of the worlds. And how you unlock these things is by completing quests, completing achievements, and then you get experience that allows you to unlock the new worlds and unlock new characters as well. So enough of the details of what is Squadbusters and what is Supercell. Let's actually talk about the launch. So we knew that the launch is approaching. In terms of a little bit of the history and timeline, we came out publicly about the game in 2023, so a year and a half ago, with 2 closed betas. So we had an invite-only betas in limited locations in the world, just to try out the game mechanism. Does it fit the players? Do they enjoy it? And then earlier this year, we announced that we're going to go soft launch. And in our case, in Squadbusters' case, the soft launch meant that we're going to go with certain limited countries around the world. So we had like Nordic countries, Finland, Sweden, Norway, Denmark. We had Canada, we had Mexico, and I actually now forgot, but we had a couple of countries in Asia Pacific as well. So we got a little bit of a probe of like, how is this going to be a market match? And during that soft launch, in a couple of weeks' time, we actually then decided, yeah, we're going to go live. And then that happened in May 29 this year. And the ambition level for this launch was high. We aimed it to be our biggest launch ever. So that was kind of the setting stone here, that we wanted it to be the biggest launch ever in Supercell's history. And to help us boost that, we had a lot of cross-platform, cross-game promotions in our other Supercell games. So you could see that new game is coming out. You can play with your familiar world, your familiar characters from those other games. So that was part of the marketing and kind of preparing for the launch. And we also, in different app stores, the Apple App Store and the Google Play Store, we had pre-registrations, which means that you could actually sign up and say, I'm interested to play this game on the day of the launch, which also caused the game to automatically download into your device on that launch day, that it's ready to play on that day. And on the right, you can actually see that we had over 40 million people sign up in the pre-registration, unlocking all kinds of rewards for the players as well. But we knew that we had 40 million interested players out there wanting to come in, potentially on the first day. And also to help us with the launch, we had a lot of collab with the different content creators, Twitch streamers, different YouTubers, creating content in terms of what is the strategy guide, how to get started on the game, etc. So there was a lot of buzz around the game. But that also meant that we knew that we have challenges in front of us. With the 40 million people being already pre-registered, we had to figure out how many actual servers will we need to be able to serve those people. And where in the world will they be? This is a global launch. We're going to launch it everywhere at the same time as well. So we had to figure out how do we balance, what locations in the world will we choose to serve these players. And of course, typical for the game launches is the launch spike. So how do you handle everyone rushing in on the first moment, the thundering horde, when you open the game? But to answer all those questions, I'm going to hand it over to my colleague Tommy, who's going to actually dive deeper into the technical solutions and how we answered to these challenges. Here you go, Tommy.
Thanks, Toni. Good afternoon. My name is Tommi Korpola. I'm a server engineer and have been at Supercell for 12 years. I've attended many re:Invents, but this is my first time presenting. I'm really happy to tell about our journey because I think we had a cool launch for Squadbusters. I still remember the feeling when marketing was telling us about all the planned activities for this launch. I was thinking to myself, oh no, we're going to be in trouble. There's going to be so many players. I wonder if we're going to handle that amount of players. It kind of reminded me of Heyday, our first game launch in 2012, where we also had too many, or like way more users than we anticipated and had some scaling issues, to say the least. I have actually many stories about Heyday, but I won't be going into that now, but you can ask me later, for example, in the Q&A or after the session. As Toni mentions, Supercell has had many launches already, and they've been getting bigger and bigger because marketing always wants to have way too many users at launch day. So now the real question was like, how big will the Squadbusters launch day be? But before looking into the launch itself, let's dive a little bit deeper on what's under the hood of Squadbusters. So Squadbusters is a real-time multiplayer game where the simulation happens both on the client and server, where the server is being the authoritative one, because you can't really trust the client. There's too many people who would like to hack. And they do hack if you allow them to do that. The simulation is updated every 50 milliseconds, and so it's fairly often that we update the simulation. The battles are also quite latency sensitive, so that's why we want to keep the battles running as close to the players as possible. Another characteristic of Squadbusters and all our games actually is that they are stateful services. You might be wondering why we're using stateful, as stateless is way more popular nowadays, especially here at re:Invent. All you hear is stateless, something stateless that. But for games, stateful makes actually a lot of sense, because in games, you typically want fast reaction to client actions. So that's why in our games, the client responds to player actions right away without waiting for the server. The server then later executes those same actions, and it compares client's checksums with its own. And if those match, the game can continue. But in order for that server to validate those actions, it needs the same game state as the client has. So the game state needs to live somewhere. By using stateful approach, then we can keep that game state with the application, and we don't need to rely on any external cache or even database for storing that game state. Another thing that is helpful for the stateful approach is that we can control how often that game state is updated back to database. So that also reduces the database load. Here you can see the overall architecture. It looks simple, but it's highly scalable. We can scale up to millions of concurrent players. Basically, everything here is scalable. On the left, we can see the main site that is handling everything but running the battles. And on the right, you can see a battle site where the actual battles happen. And we have those battle sites spread around the world in different Amazon regions so that they're close to the players. Although this is a simplified world or simplified drawing of our architecture, we don't have too many dependencies on AWS services. Reason for that is that many times those services were not implemented at the time we needed those. One example is Amazon GameLift that has many interesting and useful services, but it wasn't sadly available at the time when we needed that, so we had to implement it ourselves. And to be fair, we are a little bit control freaks. We like to control our own destiny, and especially when there's issues, it's handy when you can actually dive deep into the implementation and even fix the bugs fast. So let's go over what happens when the game is started on a device. So when you open the game, the client first wants to connect to something that we call a proxy instance. It gets that address from a round-robin DNS, and then it makes a TCP connection to that proxy instance. And that TCP connection is kept alive as long as the game is running on the device. Once the client connects, the server or the proxy instance tells the client whether there's new content to be downloaded. And if there is, we download that from Amazon CloudFront. We then log the player into the game, and the actual logging in happens behind the proxy in an instance we collectively call service nodes. But the service nodes are actually tailored in different use cases, so there's one for logging in. And when we log in, we load the player state from Amazon Aurora. After login, the main site tells the client which of the battle sites are active at the moment. And then the client makes UDP pings to all of those battle sites. Why does it do that? It needs to know what is the latency to all those battle sites, so it knows which one is the preferred one for this player. We send that information back to the main site, and the main site uses that for matchmaking, and we also use that for analytics. The map zone here shows the average latency around the world, collected from players around the world when they've been battling. And the blue color is good latency, red is bad, and yellow is something in between. We use this map and that information, what we collect, to understand where in the world the players are experiencing good latency, and where would we need to add new battle regions so that they would have a better experience. So looking at this map, you could argue that, for example, Latin America would benefit from having a new battle site. But it's not so simple, because then if we would add a new battle site there, we would decrease the matchmaking pool. So then the getting into battles would take longer for those players. So it's always a little bit of a balancing act, how many battle sites to have. Now let's look what happens when the player wants to battle with other players. The matchmaking is using the latency info we collected at login to find an optimal battle region for this player. But of course, we need to find players with a similar experience. So it might not be always the best, but we try to find a good enough place where the battle happens for all the players that are going to join that battle. Once a suitable battle region is found, the matchmaking then prepares a battle server instance for this battle. It tells it how many players are going to join, what map and what game mode are we going to play, and things like that. And then the battle server instance in turn tells the main site its connection info, like the IP and port where the client should connect. And we send that info back to the clients that are going to join this battle. The client then connects to the battle server instance using UDP. We use UDP because it has a better latency. And once all the clients are connected, the battle can start. But it's not only your battle that's running, that single battle that is running on the battle server instance. They actually run hundreds of battles. And we are able to scale the number of battle server instances as needed. So when there's like more battles needed in some area of the world, we can increase the amount of battle server instances there. We do that because it doesn't make sense to run a lot of battle server instances in a region that is in the middle of the night, so people are sleeping and there's nobody playing. So then it makes sense to dynamically have change the number of battle server instances per region. Once the battle ends, it takes about 4 minutes for the battle to last. The battle result is sent back to the main site, and player state is updated to Amazon Aurora. Using this approach, we don't actually have to have a database connection in those battle server regions at all. It's only in the main site. That's where the databases are also running on that main site, US East 1. Speaking of Aurora, you might be wondering why we're using Amazon Aurora and not, for example, DynamoDB. There's a history behind that. When we started Supercell, we selected MySQL because it was just something we knew from the previous companies. And we were, in fact, self-hosting the MySQL, running it on EC2 instances ourselves. And once the first game became more popular than we ever anticipated, we quickly needed to implement sharding so that we could have more than one database instance running for the game. So we did the sharding in-house. Then the games became more popular, then we were adding more and more shards. And over time, the maintenance burden of handling the failovers and replications started to be a little painful. Our biggest games have something close to 100 shards nowadays. So when Aurora was introduced, the timing was perfect for us. We were already looking for our alternative. And we've been really happy with Amazon Aurora. In fact, all our games are running on Aurora. The stateful architecture I mentioned also helps with reducing the database load because we can tune how often we save the state back to database. For this launch, we also wanted to try Aurora 3 and IO optimized and selected Graviton as our database instance. For us, it's easier to try new things on a new game, so that's why we selected Squadbusters to be the first to try these new technologies. But we are already in the process of moving all our games to Amazon Aurora 3. Some of them have already migrated. So let's look at the challenges. Tony mentioned the launch spike challenge. And we knew that the client logins could be a potential bottleneck. We see this in our other games. When we have events or after maintenance, there's a lot of people logging in at once. Fortunately, this is a challenge that we already have solved for the other games. We just need to have enough of those service nodes that deal with the logins. And that solves that issue. For Squadbusters, we have few lifelines also. When a new player starts the game, they go into a tutorial. And that tutorial is actually played offline, so it doesn't burden the servers too much. The other lifeline is the time zones, so not everybody's going to be awake at the same time. So that's going to spread the load also. The other challenge was to estimate the number of servers we need. And for that, we needed to estimate the number of players we're going to get for the launch day. We estimated that we would get at most 4 million concurrent players for the launch day. How did we come up with that number? Well, we had the 40 million pre-registered players that Tony mentioned. And if you just do crude math, you can divide it by 10 and you get a rough amount of concurrence for a day. But we also knew that not everybody would be coming that has pre-registered on the launch day. The other data point we had was the analytics data from our other games. And we were pretty sure that like 4 million would be enough. So using that figure, we could estimate the server amounts. Our main site is similar to our other games, so we could get the server amounts for the main site by just looking at what our other games are doing. The battle sites were something new, so that's where we needed to do some load testing to understand how many servers we need for the battle sites. Our load testing is a little bit unique, so let's look into that. We use a custom load test client that we run on many servers to generate enough load. The load test client simulates real players. It can play the game. It can even play the battles. And it uses the same protocol as the mobile client. So for the server's point of view, it looks identical to a mobile client. We typically want to run those load tests on a separate environment that is similar to production. And at minimum, we want to run a load test that has 100,000 concurrent players, because that's enough load that you start to see issues if there's going to be issues. We typically want to go even beyond that to see where the system's going to break, because it's good to know the breaking point, like how much can you load. But we might not only want to do a load test for the whole system because it's quite expensive. So that's what we did with Squadbusters also. We were just load testing against the battle server instances to see how many battles they can run per server. Another load test that we typically run is a longer running test so that we can see issues that happen over a longer time, like memory leaks or things like that. We use Prometheus and Grafana to monitor the load testing results. And here's an example I find interesting. This is 2 different test runs against a single battle server instance, one with 200 battles and one with 250 battles. And here you can see the CPU graph of those test runs, with the blue bar being the top CPU load that the server can handle. It might seem that like even with the 250 battles, we are only halfway to the maximum on the CPU load. So it's easy to see that like you could even add more battles, and that's certainly what I thought when I saw this, that okay, we can increase the load. But if you look at another graph, this tells whether the simulation I mentioned earlier is able to keep up with the load. With the 250 battles, it's already falling behind. So the lesson here is that by just looking at CPU graph alone, it doesn't always tell whether you are overloading the servers or not. Like if you would have had the 250 battles, it would have been a bad experience for the players. When load testing, it pays off to document your load testing runs, because you're going to be doing a lot of load testing runs. And you'll forget like what results was this. And as a bonus, if you make screenshots, you can use those for your future reInvent presentation as well. I wanted to include also some load testing results, but bear in mind these are workload specific, so it might not apply to you. Our aim was to use C7 family to running the battle servers. So we were testing different C7 architectures. And for our workload, the C7G had the best price and availability. Based on feedback from AWS, we heard that C7G wasn't available in all the regions we wanted to use it. So that's why we also tested C6G. Another interesting thing we saw when load testing was that if we would use a bigger instance size, it was actually performing worse for our workload. The reason was that we used Java, and the Java garbage collector was giving us more pauses when we were using a bigger instance size. So that's why we went to 2x large, which is fairly small, but it just worked better for our workload. At this point, we were ready for the launch on our side, but we wanted to utilize all the available help to have a successful launch. Our aim was to minimize the unknowns, and we thought that we had already identified the unknowns on our side, but we had limited visibility to AWS side, even though we work closely with Amazon already. And we thought that it would be good to have dedicated support engineers to help with the launch, before the launch, and also especially during the launch when we have all the players coming in at once. And that's exactly what you can get with AWS Countdown. But to tell more about AWS Countdown, I'm going to hand over to Phil.
Thanks, Tommy. As Tommy mentioned, Supercell used AWS Countdown to help with the launch. But as many of you may not be familiar with what Countdown is and how it can help, we wanted to give some background and explain how you can use it along with AWS support to help support your game launch. As a reminder of the AWS support tiers, similar to how Worlds and Squad Busters evolve with your player journey through the game, AWS support has different tiers, 4 different paid tiers to align with different customer maturity levels. So the first is developer support for customers who are doing testing or early development on AWS. And then we have our business support for any customers doing live game workloads in the cloud. And then after that, we have enterprise on-ramp and enterprise support tiers for our most mature customers running business and mission-critical workloads on AWS. Those enterprise tiers also come with designated technical account managers, such as myself, and access to proactive programs, such as AWS Countdown. So what is Countdown? Countdown is an engagement from AWS support that offers architectural and scaling guidance, as well as operational support during the execution of planned events, such as game launches. For these events, AWS Countdown will help you optimize planning, leverage expert knowledge from AWS support experts, accelerate troubleshooting through dedicated support engineers, enabling you to launch your game with confidence in the AWS platform behind the game. AWS Countdown is an entitlement included in your enterprise and enterprise on-ramp support tiers, and is also a paid option from business support customers, and is led by a technical account manager. There's also a premium tier option that Tommy mentioned that is led by designated or dedicated dedicated cloud support engineers, from AWS support, and also provides 24/7 coverage through the execution of the live event. So around the clock, around the sun coverage from support engineers. A way to think about this is AWS Countdown is like building your squad. So you can supplement your game teams with the expert knowledge they need and support to make the launch successful, whether that's capacity planning, conversations with your technical account manager, or deep dives on a particular technical topic you need help on from cloud support engineers. So let's look at a typical timeline for a Countdown engagement. So Countdown is a phased process, and we typically ask that you would engage us about 6 to 8 weeks prior to any event, just so we have enough time to plan through and document anything that we need to work on and plan for prior to the event. This is flexible, and if you have something coming up in a week or two, we can still work with you and help out where we can. During initiation, this is when we assess sort of what your goals are for the event. So for Squad Busters, it'd be things like what the soft launch plan is, what countries, how many users, and talking through what the sequence of events are. And then we take those outcomes, work through assessing your AWS environment to make sure it's built out and ready to meet those needs and achieve those outcomes. You can then launch your game knowing you've sort of looked at everything and feel more confident in the launch. And after everything, we will have a review with you and assess any lessons learned, things we missed, and take that in and prepare for the next launch. But enough of the theory. Let's look at how this was applied to the Squad Busters launch this year. So for Squad Busters, we were tracking the launch as part of the long-term enterprise support engagement between AWS and Supercell, but formal planning started about 8 weeks ahead of the soft launch date, where we had dedicated cadence meetings with the squad team dedicated to planning the support and assessing what we needed to do to make the launch successful. As Tommy mentioned, they had a pretty high ambition for the launch, and we identified the target player counts we were looking to achieve as the key metric. And early on, Supercell decided to leverage Countdown Premium for that dedicated support engineers during the launch to provide the highest level support and assurance for the launch. And some examples of some of the decisions that AWS Countdown helped guide Supercell on during the Squad Busters process. So the first, as Tommy mentioned, Supercell do an extensive amount of load testing and had settled on C7G as the best price performance point for their instance family. But AWS support helped evaluate exactly where and when this was available. And then in some regions they were looking to launch, like Sao Paulo, for example, this was not available at that time, and so we helped assess and guide on alternatives to look at and load test ahead of the launch. So if anything were to happen with availability and capacity, they had backup options available. And the next was region selection. This is specific to selecting different regions in Northeast Asia, which was the best fit for a battle site, taking both the latency information that they mentioned as input, as well as capacity information from AWS, assessing where the best fit was, eventually settling on Tokyo over Osaka or Seoul as the best region, both for mainly for availability of C7G. And lastly, we talked through different capacity reservation options. So anytime you're doing a big launch or planned event, one of the key things to keep in mind is that you need to have a lot of capacity right at this particular point in time. And there are various different mechanisms within AWS that you can use to guarantee that capacity, things like zonal reserved instances or on-demand capacity reservations. But you can also choose to prescale and rely only on on-demand instances as well. And we helped inform Supercell the different options there. But as for what they eventually chose on how to plan their capacity, I'll hand over to Tony to talk through that and the rest of the launch.
Thank you. Yeah, let's actually take a look how did the launch day go. As mentioned, we wanted to eliminate the unknowns, so we had to do some decisions based on the load testing and all the feedback we got from the AWS Countdown team. So we just decided to go with, we want to set the minimum capacity for our autoscaling groups at a high level for the launch day itself. So even though we are able to do it completely dynamically, so it would automatically scale up and down for the launch day itself, just to minimize how long the players wait for the games to start, we just wanted to set the minimum really high. Also, we opted out not to use the capacity reservation mechanism because we already, week before the launch day, we started scaling up the environment towards that new minimum that we were aiming for. So already a couple of days before, we were able to reserve all the capacity we needed, and we knew that we didn't have any updates that we would have to roll out a new autoscaling group. Were not coming up, so we decided we don't need to do the capacity reservations because it would be a little bit of extra work and wouldn't give us any kind of benefit because we already had cached enough servers for the launch, in our own opinion at least. So the launch day looked like, we had 2,300 servers across 7 different AWS regions around the world. You can actually see on the right side again, a little of the locations around the world. So a couple of in US, a couple in Europe, then one in South America, and few in Asia-Pacific areas as well to cover the global player base. And this meant that we had over 15,000 CPUs ready to run those simulations for the games and the battles. Plus, of course, all the supportive services as well, like the login service and proxy service. And we had over 20 Aurora clusters ready started, ready to serve the players coming in, so we could spread the load evenly across these database clusters without creating hotspots as well. So we were really prepared for this game launch. And on the launch day, we can actually see the people getting together in our office that was turned actually into a Squad Busters world for that specific day. You can see there is a mix of those content creators coming together to make videos from the launch day as well on site with our game team itself being mixed in there. I think Tommy is somewhere over there in the middle there around the portal circle in the middle. And as said, there was a lot of marketing around this as well. So we had a lot of in real world marketing in different notable locations around the world. And we also had a big launch trailer on the launch day as well with notable people appearing in the launch trailer as well. So some Hollywood stars, some YouTube stars, some just TikTok stars as well. So something for everyone, so to speak. But how did it actually go? So if we look at the timeline over there, at 7:30 a.m. UTC time, just to make it a little bit easier to follow the timeline, we decided to put the game live on all the app stores. And what you see on the middle there, it's a little blue line. That is the base concurrency players at that moment when the soft launch was still ongoing and we were just flipping the switch to put the game available on the app stores. And thus, 30 minutes later, we already had the spike going up to 200,000 concurrent players were already coming in 30-minute mark. And then if we waited a bit more, just 1 hour later, we already crossed the 500,000 players concurrently playing the game around the world. And all of this happened before even we did any marketing. So the real world things you just saw, that didn't even happen before 11 a.m. UTC time. So all these people coming in, the 500,000 were just players that, they noticed that it's available. They saw somewhere that it's available. They started playing. So that was all before marketing. And then again, an hour later, we already crossed the 1 million concurrency mark as well. So not as far as the 4 million that we were aiming in terms of preparedness on how many servers we had, but we were already going in a good direction. And then we can see the rest of the day, 24 hours as well. So you can clearly see we continued a little bit up, but as Tommy mentioned, the time zones are real. So you can actually kind of imagine there, where is the Pacific Ocean in that graph, because kind of nothing happens during that time. And then it starts going up again when the morning starts in Asia there, and we are going for the next day. So that's overall how the launch date looked in terms of concurrency. And here you can actually see our happy 3 server engineers on the front row there, being happy around the 11 a.m. when the marketing starts. Everything is working, so they were having burgers and drinks. But what you don't see in this picture is that on top of these 3 gentlemen here, Janne, Tommy, and Tommy, there is a big group of people such as myself who are supporting them to make the launch ready. So there's people like myself handling AWS type of questions, how to handle loads, contacting Phil. There's people working on the customer support systems, on the analytics systems, and so on. So even though the game team is independent, just 3 guys taking care of all the things of backend for this specific game, there's a big supporting infrastructure for them in terms of other people helping them out. And talking of those time zones, they do really matter. So here's actually an animation of real time of people logging into the game. So whenever there's a flash, that is someone launching the game, coming real time through our analytics pipeline. And you can clearly see, like when it's midday in this picture in Europe, there's still action in Asia because it's still like 9 p.m. They're still playing games, but US is quite quiet at this moment. So it really helps with the launch as well. And you could see in that graph as well that when is the Pacific Ocean coming in. And if we would have this run 24-hour animation, you could clearly see that the blinking lights follow where the sun is. So your follow the sun it's a real thing in the gaming industry at least. And let's talk about the results. It was our biggest launch yet. So we were happy with the launch. And we were also happy because it was the most boring launch as well. There was no major issues happening during the launch. So everything worked really nicely for us. We had enough capacity, all our supportive systems worked as well, so it went smoothly. And as you can see, we were prepared for over 4x more load for this, which meant that we were kind of having a bit too much capacity, but we quickly after the launch day released it to the auto-scaling. So it started just following that graph automatically instead of being capped into supporting the 4 million concurrency. And also during the launch day, the Countdown engineers, we had the Countdown Premium, the Countdown engineers did contact us to warn us that one of the AWS regions and one AZ in it is potentially running out of capacity for the instance types that we were using at that day, which was nice. We got pre-warning. We just knew that we had enough instances, so we were not worried, but it was really nice that we had that pre-warning that if something starts happening, we start seeing errors, that we already know what is causing the errors to happen. And what is the number? Yeah, we had 17 million people join on the first 24 hours to the game. So out of the 40 million, we had 17 million come in, which is really great. And it was, as said, the biggest launch we have yet had in our history. So what are the takeaways you can have from all of this that you just heard? As Tommy mentioned, eliminate the unknowns. That was really what we were aiming on with this launch preparation, is eliminate all the possible unknowns that we could face during the launch. Working on that is as well, I would recommend all of you do make good load testing, because it will give you the experience of the behavior of your workload before you go live. Or even if you have just a new event coming in with your existing service, do a load test. Figure out how the new feature changes the behavior of your workload. And do check the quotas, not just your own quotas, not just AWS quotas, do check all kinds of quotas you have around you, because there is oftentimes even unexpected things that you can find around the world in terms of quotas in different services that you might be depending on. Like we're depending on customer support services. We don't build them ourselves. We're a gaming studio. We don't do support softwares. So do check all of these kind of systems that are linked into the success of the launch, and check that everyone else is also around you prepared for the launch, and check the quotas basically. And do involve the AWS team, your account team, and if you have access to it, the countdown team as well early on, because we felt that the biggest benefit, the biggest value we got out of this was the preparation. Not really the launch day, but the actual preparation discussions we had with the countdown team to figure out what do we don't know, how do we eliminate those unknowns. Yeah, that's the takeaways. And I was asked by AWS Games team to also share you with some resources as well. So there's some solutions and resources for different kind of solutions, how to run your game workloads on AWS. And apparently a few more. And there's also, the last one is actually cool. It's a game industry guide to reinvent. So there's plenty of other presentations about game launches, game infrastructure on AWS on that last QR code. And with that, we want to thank you for listening in. And looking at the time, I think we have time for 1 or 2 questions. So if there's any questions in the audience, please put your hand up and then we can go into those questions. But other than that, thank you.